In today's video, we are going to be simplifying exponential expressions. So we're using the laws that we learned from multiplying, dividing, and power to a power exponents. We're using the skills we've learned in zero and negative exponents and applying to all those as we solve these more advanced types of expressions here. All right. So again, you're going to pretty much follow the rules of PEMDAS. All right. If you see parentheses, simplify anything inside the parentheses first. Fractions, you only can simplify the top and the bottom before dividing them at the end. All right. So like these first two problems, you have to simplify this top part first before you use the bottom. Same thing here. You got to simplify this first before you use the top. All right. So knowing our laws of exponents, when I look at the top here, I have exponential terms with the same base. And whenever you're multiplying terms with the same base, you keep the base. You keep the base and add the exponents. So 0 plus 3, which is 3. And then I have the bottom there, right? So then, again, we go to the next step. To simplify this, you keep the base and subtract the exponents. So that would be 3 to the 3 minus 2, which is 3 to the first, which is just 3. So this entire thing simplified is 3. Okay, let's take a look at here. I have to simplify the bottom first. 2 to the negative 8 times 2 to the negative 7, right, is 2 to the negative 8 plus negative 7. Two to the negative 8 plus negative 7 is 2 to the negative 15th. So again, we have a fraction where we keep the base and subtract the exponents since we are dividing. So it's 2 to the negative 6 minus negative 15, which is the same thing as adding 15. So negative 6 plus 15 is positive 9. And I don't have to simplify that any further because it's already a positive exponent. Okay, let's take a look at a few more examples. All right, over here, simplify the fraction first before you multiply this to 2 to the 8th, right? So over here, we have 2 to the second divided by 2 to the negative 8, right, which is 2 to the 2 minus negative 8. 2 minus negative 8 is 2 to the 10th times 2 to the 8th. Keep the base and add the exponents. So you would get 2 to the positive 18. Let me do this in a different color. All right, so we have 6 to the 0. Automatically, I know what 6 to the 0 is. All right, so I know this is 1. So it's going to be 1 times whatever this is, right? Keep the base, subtract the exponents. 6 to the negative 5 minus 4. And anything times 1 is a self, so I can just, it's basically just whatever this is, right? So 6 to the negative 5 minus 4 is 6 to the negative 9th, which is, remember, negative exponent, we got to flip it, 1 over 6 to the 9th. All right. Let's take a look at another one. We got parentheses in these. Remember, anything without an exponent has an exponent of 1. So we keep the base, add the exponents. Six to the 2 plus 1 is 6 to the third. To the negative 6, power to a power, right? 6 to the third times negative 6. Which is 6 to the negative 18th. And when I simplify that, I flip it and make it over 1 over 6 to the 18th. All right. The next one, again, anything to the 0 power is 1 times 2 to the negative 2. This is a simple one. So we have 1 times 2 to the negative 2 is 2 to the negative 2, which is 1 over 2 to the second. There's my simplified answer. Let's keep it going. Ooh, fractions. Okay, inside the parentheses, again, you have to simplify whatever's inside parentheses first. 5 to the negative second divided by 5 to the negative first. You keep the base and subtract the exponents. Be careful here with all the negatives. So it's 5 to the negative second minus negative 1. Which is 5 to the negative first power. Negative 2 plus 1 is negative first power. And power to a power, you keep the base and multiply the exponents, which is just 5 to the positive 4. And since it's a positive exponent, it is completely simplified. All right, the next one. I'm just going to move it over a little bit. All right. We have parentheses here. We can't really simplify anything, but we can do this. We have power to a power, right? 5 to the negative 5 times 4. You multiply the top. You multiply the exponents, I meant to say. All right, and that is equal to 5 to the negative 20th over 5 to the 5th, which is 5 to the, you have the same base, and you subtract the exponents. So be careful. 5 to the negative 20th minus 5, which is 5 to the negative 25th. And that as a positive exponent, you have to flip it and make it a positive. So it's 1 over 5 to the 25th. There we go. All right. So breaking it down again, you had to do power to a power. Again, negative 5 times 4 is negative 20. Then you have to subtract the exponents. Once you have the negative exponent at the end, you flip it to make it a positive. All right, let's see if we have any more. I think there's one more. Yep, just one more here. All right. This one, 4 to the negative third. I'm leaving that on top. 4 to the negative third. Anything to the 0 power, again, is 1. All right. But you could use the power to a power rule. 0 times negative 3 is just 0 times negative 3 is just 4 to the 0, which is 1, right? So technically, there's two ways you could do this. You could say 4 to the negative 3 times 1, or you could say 4 to the negative 3 minus 0, right? Which is, again, they're both going to equal 4 to the negative 3. Doesn't matter how you got there. Okay, so there's different ways you can do these problems. And now, since I have a negative exponent, I have to flip it. I'll write it over here. 4 to the negative third is equal to 1 over 4 to the third. Okay, so with a lot of these problems, it doesn't matter how you get to the answers, right? One way I might do it might be a little bit different way than you do it. But again, just focus on making sure you get a positive exponent at the end, and you're keeping track of your exponent laws, right? So for here, you could have went this way. You could have done 4 to the negative third divided by 1, which is just 4 to the negative third, or you could have done 4 to the negative 3 minus 0, which is 4 to the negative third. So, and I think there's other ways you could do that with these other problems over here. Is there another way it could have done? No. Maybe with this one having 2 to the negative third times 0, having 2 to the 0. So then instead of having this one would be 2 to the 0 times 2 to the negative second, which you still get 2 to the negative 2. All right. So again, there's different ways you can do these problems. But again, it's important to know the laws of exponents before applying these. And I know we're dealing with a lot with negative numbers, so use your calculator if you're not good with doing addition, subtraction, multiplication, with negative numbers. All right, so that's it for today's video. Thank you for watching, and remember, whether you're solving for X or Y, always give math a try.